I turned on the light. Do I look better? I don't know. It's kind of harsh light, but still. I was looking like the Crypt Keeper in those last few videos. So, anyway, here is a KSP problem. Please don't disregard that. I, for some reason, made my bracket backwards. So, a solution of silver iodide has a silver concentration of 9.1 times 10 to the 9th molarity at equilibrium. What is the KEQ? Okay, so if you think you know something about KEQ, stop the video right now and just calculate this. So I'm going to set this down, and the first thing I'm going to do is show you the dissolution equation. So AgI is going to be a solid salt, and we dissolve it in water, and it does not dissolve in water hardly at all. It's like put near insoluble. But you know, even something that's insoluble, that little bit gets in there. So you get I negative AQ. Okay. So this is a 1-to-1 salt. It's pretty simple. You see that here, there's your AgI, and you know that the silver has to be a +1 because it's only paired with one iodide, and iodide, because it is a halogen, has to be a -1. And then, you know, what little dissolves like this. So you got a positive silver ion and a negative iodide ion. And then you do a K statement, and in this case it's a KSP because the reaction is the dissolution of a salt, and you get rid of the solid salt when you do your K statement because solid, okay? So your KSP is just Ag plus and then I negative. And so what you realize when you look at that is however much silver you have to have that much iodide, because when it dissolves, for every 1 silver you get 1 iodide. So 1 silver, 1 iodide, boom, boom. And then I just look, and they were nice enough to give me a number here. And so I'm just going to put an X in for silver, an X in for iodide. X times X is not 2X, it's X squared. So I'm just going to do X squared there. And then I just take this number, there it is, and square it. So 9.1 times 10 to the -9th, and we'll square it, and that's going to be the KSP, and it's going to be exceedingly small. Let's see, 9.1 times 10 caret -9. Okay, and I want to take that, and I want to square it. Yes, and so I get, if I keep my sig figs, 9.1, 2 sig figs, so it goes 8.28, so I'm going to leave it at 8.3 times 10 to the -17. So you can see that not a whole lot of that silver iodide stays in solution. And y'all, have a great day.